In the previous video, we talked about the formula for finding the angle between two vectors, as well as the fact that the dot product of two vectors u and v can be written in this manner. U dot v equals the magnitude of u times the magnitude of v times cosine of the angle between u and v. For the first example in this video, we have two vectors, u in the ijk component form, 1i minus 2j minus 2k, and v equals 6i plus 3j plus 2k. Now keep in mind that's the same as writing 1, negative 2 for my u vector, and 6, 3, 2 for my v vector. What we want to do is to calculate the angle between the two vectors. So we're going to calculate the angle between u and v, which means we're going to use this formula. Theta equals cosine inverse u dot v divided by the magnitude of u times the magnitude of v. And so we need three calculations before we can begin. We need that dot product of u dot v, and also both the magnitude of u and the magnitude of v. So before I start, I'm going to calculate those. The magnitude of u, it's the square root of the sum of the squares of the components, so 1 squared plus negative 2 squared plus negative 2 squared, which is 1 plus 4 plus 4, the square root of 9, which is 3. The magnitude of v is the square root of 6 squared plus 3 squared plus 2 squared, which is 36 plus 9 plus 4, 36 plus 13. We have the square root of 49 or 7. And u dot v, u dot v. So in order to find u dot v, I'm going to say 1 times 6, my I components, plus my j components, negative 2 times 3, plus my k components, negative 2 times 2. This gives me 6 minus 4, u dot v is equal to negative 4. Therefore, theta equals cosine inverse of, in my numerator I have u dot v, or negative 4, and in the denominator I have the product of the magnitudes of u, 3, and the magnitude of v, 7. So this becomes cosine inverse of negative 4 over 21. And typing that into my calculator, I would get 1.76 radians if I was in radian mode, or approximately 100.98 degrees in degree mode. One thing to note is that that dot product was negative. We ended up with an obtuse angle in quadrant 2, greater than 90 or less than 180. If this had been a positive dot product, we would end up here with an acute angle in quadrant 1. Let's look at one more example. For our second example, we're going to find the angle theta in our picture, or the angle at vertices C, in triangle ABC. And it's determined by these vertices, A, 0, 0, or at the origin. B is 3, 5, and C is 5, 2. So the angle, let's think about using vectors here. The angle is identified as being part of vector CA as well as vector CB. Okay, so we have CA extending from C toward the origin A, and CB extending from C towards this vertex up at B. Now, how would we identify these vectors? So if we were talking about the vector from A to C, we could say in component form, since this starts at the origin, that this is the vector 5, 2. But since we're talking about CA, that's the reverse of AC. So CA would be identified as going -5, -2. We went 5 to the left and 2 down from that point to get from C to A. Similarly, CB. There are a few different ways we can think about it, but CB is the subtraction or the difference of AC minus AB. So CB equals AB minus AC. So A to B, and we know that that's the first one because this is where my difference originates. A to B is 3, 5 minus AC from A to C is 5, 2. So that gives me 3 minus 5 is -2. 5 minus 2 is 3. So for the sake of making our calculations easier, I'm going to let CA be equal to U. CA equals the vector U. And CB is going to equal the vector V. And what we need to find is the angle between U and B. So that's going to be including the dot product of U and V, the magnitude of U, and the magnitude of V. So we can think about it this way. Theta equals cosine inverse of U dot V over the magnitude of U times the magnitude of V. So let's do those calculations. U equals -5, -2. Therefore, the magnitude of U is the square root of -5 squared plus -2 squared, or the square root of 29. V is -2, 3. So the magnitude of V is the square root of -2 squared plus 3 squared, or the square root of 13. And U dot V is going to be -5 times -2 plus -2 times 3, or +10, take away 6, U dot V equals 4. Therefore, theta is cosine inverse of U dot V, which is 4, divided by the magnitude of U, root 29, times the magnitude of V, root 13. And that is cosine inverse of 4 over the square root of 377, which, plugging that into our calculator, gives us approximately 78.1 in degree mode, or 1.36 radians. So that gives us the measure between both of those angles. And again, you'll notice we have an acute angle between 0 and 90. That dot product was a positive value. All right, both of these lengths are always going to be positive. So cosine inverse of something that is negative is going to be in quadrant 2 or obtuse. Cosine inverse of something that's positive is going to be in quadrant 1 or acute. So in this video, we did 2 examples of finding the angle between 2 vectors.